All right, everyone. Welcome back to another installment of me streaming, working on open source stuff. So what we've been working on the last 2 weeks has been, actually the last 2 times, because I did it twice last week, is a stream processing library for Node, which is based on Kafka. So using Kafka as the source of all the events or of the stream and processing that in some meaningful way. So actually since last time I've done a little bit of work off stream, meaning that because I've started this project in TypeScript and I'm pretty new to TypeScript. It's the first actual meaningful code I'm writing in TypeScript, and I definitely have it definitely cost me a little bit of time while working on it. Last couple of times, rather than working on the really stream processing specific things, and there were just a couple of issues with the code that I had written so far, and so I've gone and cleaned that up a little bit to make sure that I don't have any types all over the place, and have a couple of things actually working the way I thought they'd be working. And there were actually quite a few little bugs already in the stuff that I've written so far, all TypeScript specific, nothing really to the processing API. So I think moving forward, I think I'm gonna more heavily rely on the fact that TypeScript is supposed to be JavaScript, and mostly write stuff in JavaScript sort of ways for now, and then eventually more gradually type stuff, because I just jumped in, and turns out static typing isn't something you just jump into. Even it's sort of something I've done in the past. I worked on CoffeeScript with CoffeeScript before. And there on the first time, this is years ago, because I don't think anyone really still uses CoffeeScript for anything. Maybe people do. No shade on CoffeeScript. I liked it. Basically I got to pick that up really quickly. And I guess it's more really syntactical sugar more than TypeScript would be. And but it's still the best way I learn. Just, dive into the deep and get stuff to work, but it might not be so interesting to watch. So let's get into some programming. Right, this time I'm actually up to the point where this stuff should be readable. Can we read this on stream? Let me know if this is not big enough. I've actually... So, let's see where we've left off. So the thing that I started working on at the end of the last stream is the ability to test your processing logic without needing to spin up an entire Kafka cluster. So this is the task we're creating. This is the processor that we like to apply to it. I actually have a couple of ideas about how to change this API, which I'm going to do first. But then you can inject an assignment as if it's coming from a assignment, like as if it's coming from a rebalance, or it's manually assigned or whatever. And then there's a test message, and the idea is that using the test interface you get back, you can inject that message, and then you can basically making sure that all this processing logic gets run, and then you can assert against the outcome of that, and make sure that your processing logic is actually working or not. It's been an extremely useful thing in in development so far for us. Ever since we've added that, our tests it's been a lot easier to make tasks that are reliable, for where we know that the processing logic is sound, especially because we're still working on the framework itself as well, obviously. So it's really important that you can identify where your processing logic is wrong, or where your framework code is still has some issues. So let's have a look at that. So one thing I want to change first, and it's something really, really small, and I don't even think we've implemented it yet, but is it this task.process? I want to start calling this processor. And very, very quick reason why is because at some point I actually want task process location event, so whatever the input is. I want this, I basically want this to become a shorthand, so for this bit to become a shorthand for writing just this. So where, because a lot of the processors that we're going to be building on top of this are very simple processes that are just like map or filter or something like that. And there's actually a couple of differences between assignment, this assignment context you're getting, and this processing context you're getting. And the processing context is a more limited version of that, and I don't want people to necessarily mix those. It could get really confusing. So for the simple stuff, this should actually be fine. And only when you actually need to keep some sort of a state as part of the assignment itself, would you want to do something like this. So we're not anywhere near this yet, but it's something that I do know that we want to do, having looked at our own processing code so far. This is a change I'm gonna want to make, so we're better off making it early. So I'm just gonna change it in these examples, processor, because there's less code around now, right? So it's easier to change. And where else should we change this? I think in the task. Let's make this a bit wider because we're not really testing anything at the moment. Process, we want this to be processor. And I don't think we're really calling that anywhere, but let's just call test. And we'll watch the test and just see if everything is up to snuff at the moment. Should have probably done that before I made these changes, shouldn't I? Yep. All right, let's run that again. Run the whole thing. Sure. Yeah, okay. So it was all working. This didn't work because I changed this processor. And what was the error we were getting, which is obviously compilation error. Actually, let's just give this some more space because this stuff is hard to read. Process does not exist on type task because we were already testing it. Test task process. So we were already covering it with tests somehow. Let's take all these dot process methods and turn them in dot processor. And we're back to okay. Cool. So let's just commit that straight away. Frolic, and then oh, I forgot to change the font size on this thing. Change, rename task process to task processor. Sweet. Okay, it's not a bad start. Yeah, we've done something already today. Didn't necessarily go that way last time. So, is it useful to go over the changes I've made over the TypeScript? Probably not. Truth be told, I've probably already forgotten one or two things. Because basically, I finished the stream, and I was like, something like this doesn't feel right. Something like this isn't working the way it should be working. And I actually looked up this little bit, Istanbul ignore next, which makes it ignore this function or the next statement, but in this case it's a function, which means it's ignoring that on my code coverage. So I can already include it in types or whatever, or I can sort of plan to implement it, but I can say, okay, code coverage for now, ignore this bit. I wouldn't want to have any stable versions or pull requests that would get through with Istanbul ignore. I don't, because I think code coverage is extremely important, and a really, really good way to catch bugs. Okay, so last time we did actually. What did I change? Nothing. So last time what did we do? We worked on this task inject, and we said, okay, we can inject this other interface in order to make sure that we didn't get the same one. All right, I think it's time for a new test file and to actually start working with the interface we get back from task.inject. And we're going to start implementing that interface. New file, inject, easy. Now I've already forgotten how we do this stuff, so I'm just gonna copy and paste. This is how I basically also don't learn how I do that stuff, but you know. Interface. I think we realized that this had to be an async function. Yes, and it needs to accept T. Cool. What else did we do? T-test, and we can write a test, okay. Let's just actually implement some stuff first. Assignment context. So I started thinking that all this whole interface is actually not going to be extremely useful, but I'm just going to leave it there for now. One of the things I changed is that I'm accepting an assignment and a list of processors here, which is what was different earlier. Anyway, it doesn't matter too much because let's just actually focus on the thing we want to do. Okay, so this is the context that we're exporting. Now, this context needs to have a whole lot more things. I'm going to peek a little bit at what we've done earlier with this to make sure I don't miss anything. Have a little peek. Little peek. Okay, so what was the... Gonna need a couple of these because I'm just actually going to... we're going to have a async quote up function, which takes an offset. This will return whether the assignment that we've retrieved, if there's any committed offsets, or if we're going to apply an offset, whether or not that means that we've reached the end of our partition at the end of the log, because in a couple of ways that is important logic to have. We won't implement that straight away, but it's definitely something we'll need. Commit offset is a really important one. Also an async function. Offset, and we'll take some metadata for anyone who is, if you know Kafka, then you know offsets. Committing offsets is how consumers can keep track of what they have and haven't processed. And so if you've processed a message, every message in the log has an offset number, which is constantly incrementing. And if you commit that offset, you're basically saying, okay, we've processed this offset. So if you then go offline or you crash or whatever, and you need to restart processing, we look up this offset before we start processing, and we continue processing from there. So we don't have to constantly reprocess every last single thing, which is good. Keeping track of where we are. That sounds like an interesting idea. Now we need... I'm going to keep that out for a while. Oh yeah, the important one is empty. Now, there is some logic that you need sometimes especially in some more complex processors, whether you need to know whether the log you're processing is actually empty or not. Because sometimes you'll be waiting for messages to arrive, or you need a message to arrive to execute some certain logic. If the log is completely empty, then you can't do it that way. So you basically need to know whether you're empty. It's almost the same as if you're caught up, and we might end up combining these two things, because you could say, well, if we're empty, then then we are caught up. But some of the logic, the way that Kafka does that is a little bit weird, because basically if you don't commit an offset, it already has a committed offset, but it's -1. And anyway, we've added this at some point. We might remove it if it's not necessary anymore. We want, very important for implementation's sake, is we want the ability to log, and the logging is going to be a little bit like tags and payload. It's going to be a little bit like they do it in Happy. Instead of having log levels, we're going to have a tagging system, which I find a whole lot more useful, and actually being able to find the right logs and being able to extract the right logs. Something we'll get back to, but it's very important that tasks that we can log things that we can then forward and propagate all the way to the to the one logging endpoint for our application, so that we can keep logs and stuff, right? Yeah, you need to have insight in what we're doing. So then we've got these the topic, the partition, and the group. They're basically saying, what assignment are we actually working on? There is something that I'm not sure yet, but I'll just put it in there for now. Is the prefix. That has to do with running on multi-tenant Kafka applications, like I know on multi-tenant Kafka clusters. I might actually leave this out for now. To decide we want to support prefixes. So what basically happens if you a couple of the earlier multi-tenant a couple of the early multi-tenant clusters that you could work on had multiple tenants on one cluster, so multiple users on one cluster, by prefixing everybody's consumer groups and prefixing everybody's topics. For example, we've used the Heroku implementation, like the Heroku cluster before. We still run some stuff against that, and everything needs to be prefixed, and it's really annoying because per environment your prefix can change. It's a lot nicer, just like with Postgres or something, to run a cluster per environment, so that you don't have to do any of this prefixing. But to anyone who's run, I don't know, WordPress or something on shared hosting before, back in the day, or maybe still is, then you'll know what prefixes are good for. I'm not sure. We might put it in there. We might not. People might have to do it themselves, because it's also not that hard to do yourself, because you just, every single time you put in a source, you just need to add a prefix to it. But at the same time, it's probably also not that hard to support. We'll leave that one open for now. I think I'm just gonna leave it out for now. Two very important ones that you'll be able to do is pulse. You can pulse the assignment, and you can resume the assignment. Let's keep on these. Maybe I should actually. It's a little bit easier to see what belongs to what, doesn't it? You can pause and resume consumption. It's very important. Or is it actually? Let me think. Might be something we actually want to. Very, very, very quickly, because this is basically a bit of abstraction that we're leaking. I mean, we're leaking some more abstraction, like committing offsets and stuff. But if it's a bit of abstraction that we're looking from the Kafka consumer, because in Kafka, consumers are part of a group, and you can pause and resume the fetching of messages, and in the Java version of Kafka streams, or even of Kafka, pause and resume is used to figure out whether a node is alive or not, but we might not. I'm going to leave them in there. We might just implement stuff without it first. Heartbeat is very important. That's how we can signal that we're alive, even though we're maybe implementing a pretty long process. Async heartbeat. So basically what happens is if a consumer joins a group, it needs to tell that group that they're alive, because if the node goes down or crashes or whatever, or gets stuck in a massive garbage collection loop or whatever could happen, is we want to make sure that the group can move on, declare one of the nodes dead, and assign those partitions for processing to another node. The way that we make sure that we stay alive is by the heartbeat. We have to send that at least once in every session timeout. So the session timeout, I think by default is like 30 seconds. So you basically need to do something that shows you're alive to the Kafka cluster within 30 seconds. But sometimes you've got messages that you need to process. Sometimes you're doing quite a lot of compute, or you're doing polling or something else. And you need to make sure that despite not fetching any new messages, you're still alive. You still want to say, don't worry, we're still going. Very important fault detection mechanism. Now, another important one is async seek. This is where you get to seek to a different offset. So, the offset, so every message has an offset, comma. Every message has an offset, but at some and we're consuming these things in order. But at some point, we might want to consume from some other point. Extremely useful if you choose to keep the offset not in Kafka but in an external storage, for which there are many good reasons, which I'm sure at some point we'll get into. Not really now, but you need to be able to change from where we're consuming. Now, another one of these, send messages. We don't only want to consume messages from Kafka, we also want to be able to write the outputs. And we could write those to an external store, something like Postgres or whatever. But a very common use case is to actually write those back to Kafka. We want to be able to write to Kafka somehow, and send is the way we do that. I chose the word send basically because the producer calls this send rather than produce or something like that. But so I'm just going to go with what Kafka.js did basically. Let me think what else we need in this case. Yeah, one more. Async watermarks. I'm actually thinking that I might turn these into methods, or I mean, I guess methods don't really exist in JavaScript, but just to make sure that they're read only. Is that a good idea? Or some I don't know. Random thought of the day. Watermarks. We want to be able to figure out what the end of the log is and what the start of the log is. Where do we leave? Local 36. We want to, there is each log has the beginning of an end. There is at the beginning there is an offset, at the end there's an offset, but those aren't necessarily 0, and you don't really know how far it has gone. So you need to be able to query what those offsets are, especially when using combination with seek, for example. Say that you want to go to the logical beginning. You could do that. There's a magic offset you can use for that, but you can also wish to do it manually. We actually need this internally for the code up method in order to figure out what the offsets are, and then we can compare this offset to those watermarks. So yeah. I think that's pretty much it. Although let me think for a bit. I think that's it. Yeah. Now we're getting to one bit, is that we might need to add the stream to here. Let's start to... Wait, what are we saying here in inject? Okay, we actually want all of this to come out of this function. Yeah, we do. Because we need that in here. Context. That's definitely what we need. We didn't cover lines 51, 53, and a whole bunch. Yeah. Let me see where we're going here. We need to... I mean, that's not being covered because it's not being used, is it? For lines, does it meet the global threshold? Wait, we're actually just getting a compilation error. So let's not look at the coverage quite yet. What are we getting here? Context local, 3 to 7. Yeah, see, so we're getting in trouble with this interface here. I think... I've been thinking that this interface is not really the way we want to go anyway. This whole assignment context interface. So I think we're gonna just... Enough time wasted with that for now. We actually need to get something running, and then we can decide what the right times for that stuff is. Let's just, you know... Okay, cool. See, it's just... I've been messing around with that so much. It's just like, it's not worth it. And those things won't actually have the same interface somehow. At some point, this context is probably something that will be, that will define as an interface, so that we can make sure that it's the same between the version that we run that is powered by Kafka.js, because that's actually the point of integration here. Calling a Kafka.js consumer from all these methods, or simulating that in a mock. But obviously we want to make sure that we get the same context to, that we're exporting the same context there. So you know, at that point we might want to create an interface for that, Not going to bother that with that now, because then this is going to become another TypeScript. It's a very TypeScript specific thing, which I'm not interested in doing right now. So let's have another little peek here. So the thing is, we need some way for this inject method to inject messages into this, and for us then to feed that process, and you need a stream for that. And eventually I want to create my own Node Stream interface, my own Node Stream implementation for this. But that is complicated. It's not necessarily trivial. So I know that I said that one of the goals is very, very few dependencies, Kafka.js and long. But for now, I'm going to include in that. So I'm going to set that as a later goal. First, I'm going to say very few dependencies, Kafka.js, long. Highland. Custom node streams. And for those who are not familiar with Highland, Highland is basically, let me drag me a new window here. Highlandjs.org. Highland is basically, if people are familiar with Lodash, and I think most people would be familiar with Lodash, it's basically Lodash but for streams, for working with asynchronous stuff. Some of it is not as relevant anymore now that we have async await and proper and like promises and stuff. But for a way of at least simulating streams is extremely easy, because just have a look at this. Like, you're basically taking an array, and you turn that into a stream, and you can turn that stream into whatever, or you can take an event emitter, or all these different kind of things you can quite easily turn into streams. And they're all object streams for those who are familiar with Node. They're not buffer streams, they're object streams. But they're, especially in writing something like a mock, they're extremely useful in just getting a stream and just saying, okay, this is what we're piping through the stream. Okay, this is where the stream is now. Skip all this bit, go to the next bit. It's really easy to do that stuff without having to completely implement your own stream. Eventually, I do want to do that because I think it's useful to not to have to rely on something like that. But for now, I'm just going to go with it again to try and get all the base logic working first, and then we can get rid of that stuff. All right. Maybe actually I can say here streams. Nah, I'm just gonna not gonna do that because it's not actually a goal to have streams powered by Highland. It's just an effective implementation. So let's add that to our Highland save. See how I noticed that it actually had saved this time? Damn. See how I noticed to add the save flag but not actually use the right command? No problem. It found 0 vulnerabilities. That's how we like to see it. Cool. Because now what we're gonna add here is we're gonna add a stream here. Say from Highland. How if we could do it like that? Oh, actually, I like to call it H because you use it so much, and Highland is such a big thing. It's sort of like underscore. Actually, they in their documentation say underscore, just like underscore. But I like to use h instead, because you know everything wants to be called underscore, and let's just call underscore or low dash underscore and not anything else. All right, I'm gonna create a little stream, which is basically the stream of. So this is where each assignment gets its own stream, because each stream can in Node, a stream is something you process as a unit of, like it's basically a unit of concurrency in Node, because you're generally supposed to consume and process a stream with one consumer. You can fork it into multiple consumers, but then you get weird stuff with back pressure, because each stream gives its own back pressure to make sure that it's not reading messages faster than it can, or that it can process it, or they can write somewhere else. Well, I can just say stream, can I? So yeah, let's actually see if Highland has types. This is a thing. See, this is not something I'm used to, but types Highland does Highland have types? I think so. Does that mean I have to install it? Again, with the TypeScript stuff. Let me add that. Implement install types Highland save. Or is that a def dependency thing? How am I supposed to use types? Does TypeScript tell me? Sorry for the little bit of TypeScript stuff, but you know, I want to make sure at least I have the right files. Handbook. What's new? Tutorials. Migrating from JavaScript. Sure, they'll be talking about types, won't they? They are. Getting declaration style. If you start converting over TypeScript imports, you cannot find module foo. There's declaration files, vocabulary. Luckily, it's pretty easy. If you're using, you need to set module resolution to node. We have module resolution set to node. If you're using anything other than Common.js, well, we've got Common.js set, so that should be fine. Man, I should have read this earlier, shouldn't I? Whoops. Because I am a JavaScript programmer, so I would want to know these kind of things. Cool. All right. Well, we're gonna see how that if that did anything. Wait, isn't it then like it should stream? It should like do autocomplete stuff or something? Maybe not. Wait, I can actually look at this file, can't I? Which would be useful. Definitely typed. How do I get them? Save dev typed node. All right, I don't even know what I'm missing. So let's, whoa, is this like super big? It is super big. Does it contain everything? Cool. Oh, cool. It gives you a Highland stream and a Highland nil. That is pretty cool. All right. Let's, if it just works magically, that would be great. That would be really nice. Tommy thinks it's super cool. I'm streaming my development. Well, you and one other person at the moment. Sweet. Okay. So we've got this stream here. We're exporting it as part of the thing. Now we want to actually test this. So we want to create a task. I think there is actually a before here. This is something that I should have looked up, but didn't have the time to last night because I was otherwise engaged. Node tab. Can I not type today or any other day? Get started. The API. Yeah, before each, a few moments for a test where you might want to attach some setup or teardown logic. Node implements these using the following functions. Before each, after each teardown. Okay, looks why. Not before, because there are options for doing if. I'm just gonna set up it before each. It's not actually async. Let's. So another change I made, by the way, is that test task now requires a group, because that's the only way that this writing a task makes sense, really, because you're using basically a single consumer, and in order to like you're using consumer groups to do it, which have group names to identify which are the different groups of consumers that it should be balanced and work between. And because we want tasks to balance with every instance of that task that's running, we need that same group name. Test group. I'm sure that's what TypeScript was moaning about, the fact that it didn't have a group, right? Maybe. Coverage for lines. I don't know what it's talking about. Why is this not covered? And it was before? Am I missing something here? Hey? Okay. This is only running the one test. That'd be weird, wouldn't it? Ah, wait, so when I hit save, when I make changes here, it only tests the file I've changed. Yeah, but obviously it's not gonna reach everything from this one file. Okay. So it's basically saying, no, you don't have full coverage because we didn't run all the tests. But when we do run all the tests, you do have full coverage. What? Okay, that's something, I mean, it's useful that it's just running the tests that are different, but then why is the coverage a thing? That's complicated. Maybe we can... get around this somehow. I'm gonna get around it by just running that as a different thing for now. Delete, bye. I'm not here to... Yeah, and now the file is gone. Weird, huh? Exit. Okay. I'm just gonna continue over here. Task inject. Just gonna nest some stuff and see how we do. Because, again, that's stuff I don't want to be figuring out on stream. Because it doesn't have anything to do with Kafka or with stream processing. It has to do with this test library that I'm using. Task inject. Test. Can I just... Test interface. Cool, let's just test the test interface. Actually, let's move this in there and make that up before each of these. Let the task be might as well add the source to it as well. Source is task source. Test topic. Because you might need that again. Test group. Okay, now we can remove these, attach that processor to it, and return to test interface. T before each. Before each is not a function, but before each is. All right. Is there any reason? Test unfinished. Oh yeah. We have to basically make them async to tell it that we're done with something. Cool. This keeps binding me the way it does. I don't know. I don't know if Jest has code coverage built in this way, but anyway, okay. So it can return a test interface, and then we want to actually test that interface. Test a test interface. Makes sense, right? Can inject messages. Okay, so in this way we'll take the processor and we'll take the source, and then we'll actually try to figure out here whether or not we've message context. Well, actually, instead of actually saying that we get those, let's just say that we've pass, maybe. Let me import Xenon from Xenon. Xenon is a really handy way to make sure to spy on functions, basically. I know Jess has that built in, but we don't. So install save dev Xenon. It's a dev dependency, so it's fine, right? I think so. Q. Xenon have types. Yep, and I didn't say save dev, did I? Let's do that. Makes sense. All right. Actually, say spy, and then somebody noticed this yet? Processor. Assignments. Wait. The actual message processor, let's call it that. That's just a spy. And with this one, we'll wrap this in a spy, but it will return message processor. Now what this allows us to do is to say, okay, and then I'm gonna get the test interface. Test interface is task inject topic test topic partition 0. We don't have to supply a group because we're in that same group. And then we'll take the test interface, and then we can finally inject our message. And the message, I mean, it doesn't really have to be. It doesn't have to be anything specific. What we need is the topic, test topic. We'll need the partition. And we'll need the value of the message, which is what the Kafka message is, and a test value. Right? That's fine. Okay, at this point, once we get this bit, we should be able to say task message processor has been called, I believe. Called once. Okay. Okay, so to say what we're doing here, is this is failing at the moment because we haven't actually implemented this yet. But this is the very, very basic part of us basically injecting a message. So we're setting up a processor with a processor that we can spy on, so that we can actually see, so we can ask, but basically we can make simple assertions to see if it's been called or not. We process the source with that, and then we inject the assignment as if it happened. Actually, at this point, maybe we can actually move this over here. So at that point, it should be the process. It should have called the assignment setup of the processor setup with the assignment. We're not even asking yet where we're passing the right stuff to it. We're just asking, have you been called, yes or no, as a sort of first test. And then we take that and we say, okay, now let's inject this message and produce that. And then that should be passed to the message processor. And it's very sort of basic. And we're quite far away from actually making that work at the moment. But if that works, then we're quite a long way towards the example working, the example of inject working. Because it's basically the same thing. I mean, apart from the fact that we're actually doing something and we're calling some context methods, we're actually on our way. Actually, the structure of it is quite similar. All right, so now we actually need to start implementing that function. So let's give ourselves some space here. All right, let's see how we can do this. Let's probably accept options here at some point, but we'll just go with what we need in order to make this work for now. Also, looking at code coverage, how that might help us. Is this actually failing because of the right things? Might be a good thing to ask. Test unfinished. Test unfinished. Test interface inject is not a function. Expect truthy value. Test unfinished. Well, we don't want it to not finish. Why is this test unfinished? Because it... Okay, I'm just going to ignore that for a second and actually actually work on the assertions themselves working. Okay, so basically what we're going to need to do is mimic Kafka here. So we need to keep already. Okay, so we need to actually mimic how a log works. So we'll each log has a we'll be tracking our consumed offset. Is 0 initially, right? Produce offset we don't need yet. Let's keep current high water. Actually, let's just start at the actual bit where we're gonna be adding stuff here. Topic, offset, message. Okay, let's see how we inject a message. Let's just call this, I don't know, message. So we'll need, I'm just looking at how we implemented this, and we've already added quite a few abstractions. So, but basically we need to add ourselves an offset, because that's what every message that gets injected into or consumed from Kafka gets. It gets an offset number, so we need to figure out 0, like what should this be? 2, keep the offset here. I actually like to add the high water offset here as well, but let's just keep that away from now. So this is a bit nasty, because obviously they could insert anything into here, but that's maybe where we can start to type stuff later. Or we can do that now, I guess. Topic is a string, partition is your number, and value is anything really. I'm finding this really hard to read. Like, what is part of my last test run and what is part of my current test run? Task inject. What's wrong with task inject? What the hell? I mean, and we can basically take the stream we have and just write the message to there, right? Though we then need to set that already. Let's call that the payload. Let's create the message right here. Write the message, and then we can also return a message, because that's useful to return that, I think. Okay. Oh wait, can I write this like that? Yeah, I can do write like that. One thing that I ran in last time is when I was doing this, and then I was giving it types, but that is argument destructuring, so that doesn't work like that. Anyway, can I just clear this whole screen? Clear. Nothing. CLS. Sweet. Run. Wow, that clear really helps, didn't it? Jesus. Sure thing, man. Okay, well, now what we need to do is, okay, so we have this stream, we're injecting this message into the stream, so this is getting into this stream here right now. But then we need to make sure, we're actually consuming that stream. Actually, I'm running out of time here. Crap. That's not great. See if I can get a little bit more done. Actually, see how we do that. Task. So the problem with implementing completely non-trivial things live on stream is that, it might not work as well as you would have hoped. Okay. So we need to actually build up this stream somehow so that it actually processes. One thing we can do is we can take these processors, which is an array of processors, and reduce that processor. And we'll take the stream here. So we're gonna have to set up those processors somehow. So wait, what if we make this asynchronous? No, I'm completely mind failing here. Because I'm looking at the way we've done stuff before, but I've changed quite a bit of how we were going to do this, and it's actually making stuff a little bit more complicated now. I used to have this thing here where the actual processor pipeline would be set up somewhere else, would be set up in the task rather than in the context, and I've been wanting to change that because we've been messing with exactly once processing, where every single time there's a message, basically as it goes through the entire pipeline, you need to how do we say? You need to track it. Like you need to wrap the entire thing in a transaction. If you want to do transactions, you need to be able to do that. And basically every single time a new message comes in or a new, like you basically need to be able to manage the transaction and wrap all of the processors with it. And if the processors are being pipeline is being created in the task rather than over here, then you can't do that. But I haven't really thought yet about the actual complications that brings. So at the moment I'm juggling, like instead of just actually focusing on this tiny bit that we're writing, I'm getting a little bit, I'm thinking about those other things as well, and it's not really helping. So source, processors, reduce. Processed stream. One by one, I want to set these up. So I want to await the setup of the processor, and I want to inject context. So I want to do this below that. Oh, wait, I can't do that here, can I? What if I have multiple of those processors set up? I just need to call that thing. I need to create multiple of these contexts instead. Oh my. Do I need a context per processor? I'm not sure if this is that easy to follow along, but so we have the idea is that this is the context of the assignment, right? And per assignment we can chain multiple processors, and we need to be able to chain those. And so but even though there are multiple processors, it is still the same assignment. Like you can't say that I'm taking one source and so I'm taking one topic partition, which is basically an assignment. I'm taking one of those and I am gonna and I'm pulsing that one, but I'm not pulsing the rest, or I'm seeking that one, but I'm not seeking the rest. No, because it's all basically, this entire process thing is one massive pipeline of things. So they do all share the same context. That's for certain. But so how do these so how do I apply the processors? The processors need to be applied to the messages stream. The messages stream is this thing. But then what do I pass as that assignment thing? Is that context? Maybe that is just what I do, actually. Process message is await, yeah, and I'm hoping this is a function. Can I no, don't time script it. Yeah, don't get thrown and don't get pulled into that. So one by one, I will yes, that makes sense, I think. One by one, I will set up the processors. Can that be done in parallel? Or am I doing that sequentially? I think I'm just going to go and do that sequentially. I think it makes sense to do that. Yeah, in parallel that wouldn't make sense, because then they can change they can seek, or they can do all these different things all at the same time concurrently, and that would completely mess up their logic. So sequentially, yes, and they return a process message function, and basically we need to apply that to big silence in the stream. How can I? This is it. Here we go. So we'll take the. It's a bit of a mind bender here, but here we go. I think I've got it, and I'll try to explain. So we got the stream of messages. That's where so each time we want to set up one of these things, and then we want to add it basically as a transformation step to the messages. That's going to be a more complicated interface at some point, but I think right now we can just say that we'll just take the messages stream, and we will map. I think map. Yeah. Let's say map for now. Wait, is it a flat map? Or should we flat map this? We should flat map this. Highland stuff. So in comes the message from the stream, and we basically want to put it through our processing message. We want to be adding a little bit of a processing context there later, but that's more complicated stuff for later. Why do I make this a flat map? Because how does this work again in Highland? So you can't return an async function straight. So this returns a promise, right? So this doesn't return a new version of the message. So the stream is going in, say if this just set map, and a message comes in, and then we await the process of message, which can be asynchronous. So we await it until we pass it on to the next part of the stream, to the next processor. But it's asynchronous, so this actually returns a promise. And as far as I know, map of Highland doesn't support that directly. Just gonna look it up before I say something like that. And so what we can do, so let's just do it like this. So basically, but what we can do is we can turn that promise. So this is basically an awaiting processing. That's what this thing gets. That's a promise. I mean, I guess we can. Oh yeah, don't use the TypeScript, man. If you don't know how to use it, don't use it. But I'm pretty sure. But you can pass a promise to Highland to create a stream from. So the stream then is basically only has one output. It either throws an error like any other stream would, or it would resolve with the single value that the promise resolves with, and then ends automatically. So it's a bit of a hack, but it does mean we can do this. And then I actually need to say flat map, as far as I remember. Flat map is basically the same thing as saying, so basically it is merging this one stream back into the other stream, if that makes any sense at all. If not, go have a look at Highland, go have a look at flat map. Creates a new stream of values by applying each item in a stream to an iterated function must return a possible empty stream. Each item on the result stream are then emitted on a single output stream. So it's basically a way of then, it's how async await works if you want to do it. It is basically the same thing as calling sequence. So instead of this, we could be calling map, that, and then sequence. But why would we? So that basically means that, okay, we're now taking messages and we're creating this pipeline. So every single time we first set up the processor, and as soon as we get the processor back, we add it back to the stream. Now, this itself is an async function, so returns a promise. And so when we get that back, because this is a reduce function, so this is the input for this in the next iteration. So we have to actually wait until that's done. I think this is probably not the clearest code, but I think it's more clear for people who are familiar with work. Oh, there goes my microphone. That's not good. Hello? But I think it's familiar for people who are working with async await more. Like, it would be great if these reduce functions could just, deal with it automatically. But it's just not how it works, is it? Task, inject. No, there's one more thing that we need to add to that. Oh yeah, obviously this will now fail because that isn't something. And we actually need to start with the stream because so promise resolves stream. Is that gonna... It's gonna complain, isn't it? Because I'm using that twice. I don't know how TypeScript does that, but anyway. So here we are slowly taking all these things and applying them. Create TS error. Let's just figure out if we can make the TypeScript compiler happy before we move on. Generic type promise requires one type argument. Wait, what? Property resolves does not exist on type promise constructor. Did you mean resolve? Probably. 58. Okay. Should have known better. No value exists in scope. 66:14. What the hell happened there? Probably me trying to do the clear on tap. A wait expression is only allowed in an async function. Where am I using it? That's not in an async function. 50. Oh, is this it itself not an async function yet? Oh, well. Create context is async, people. I hope I'm calling it as such. Yep. I think it's only allowed within task 5311. Same thing. I'm really starting to lose it, aren't I? Let's make that different in the example as well. Oh, in the example we already did it correctly. It is only allowed within an async function task, or is this old? No, it's not old. Task 5311. Do an async map here. No. Like that. Man, it's getting messy. But right now I just want the thing to compile. Okay, we're back to compiling. We're not yet to a working test. Let's see why that is. Test interface inject is not a function. It is though, isn't it? Isn't it? Start implementing that so we can get rid of that. No, it's not, because we're only... Wait. Let's fix this like this for now. So basically what's happening is that we're getting an array back of test interfaces, not a test interface in itself. Test. So with this, we can destruct that. Adapt. Most of the time we'll be using it with a single assignment. Like I have seen tests where we're using it with multiple, but it's definitely not the common case. Maybe that means it shouldn't be accepting an array. I don't really like those polymorphic APIs, but accepting either one or an array of something is somehow that's always sort of worked out for me fairly well. So task inject. Wait, where does the summary results? Where does the last thing end? Is that here? Signal null? I think it ends with a code coverage, so yeah. Expect truthy. Let's just see if this actually works without that for now. Test, task inject. Test unfinished. Oh. Okay. So it's just a problem that it's unfinished now. Test task 7. Wait. The hell, people? Or is this not our task? Is it their task or something? 46. Yeah, okay, that's the one that hasn't finished. Gee, test, what's the issue here, man? What is the problem? Can anyone help me? You are work on something, at something? I'm definitely working at something, yeah. No, this is just random stuff. No, we're working on a Kafka streaming library for a stream processing library for Kafka in Node, which is complicated, as it seems. But I'm mostly still messing around with my tooling. That's the thing that's really really causing me grief at the moment. I need to go dive a little bit deeper. In the same way that I dove a little bit deeper into the TypeScript stuff, I need to go dive a little bit deeper into the Node tab documentation and figure out what this whole deal with finishing tests is, because I'm getting a lot of unfinished tests for some reason. Which could also mean that this thing just never resolves. But I think it does, right? Like, wait, task inject. Hello. Let's see if it's this point. It does. So it's not like we're stuck under that. All right. Well, I think I'm gonna go leave that for the next time. Probably something I look at because it's something very tooling specific and not really that interesting for anyone who would show up for just for the processing of for stream processing with Kafka. At least we did get to do some actual implementation. We started this whole interface and we started implementing. Applying the processors that we pass to task.process or the processor, we should say now, because we're changing that, right? So we've started applying those, and some of it is working, some of it isn't yet. But anyway, thanks for watching, and let's do a proper sign off here. Talking, yeah. Ooh, fancy. My hair is all crazy because that happens during programming a lot for me. So I'll probably do some stuff off stream to get to better grips with this testing harness, because it has stuff that I like. The whole test coverage thing is definitely working, but I'm new to it, and definitely getting some errors that I don't completely know what to do with yet about unfinished tests. Whether a test is not finishing or not is a little bit difficult for me to say at the moment, because I'm just not familiar with it enough yet. So I need to go look into that. I'll probably do that off stream, so the next time I've got that stuff more covered, then we can continue with that. I might do a little bit more programming off stream anyway, although I'm pretty busy the rest of the week and next week as well, so it might not happen. But I definitely vow to have another another programming stream going next week around the same time. I hope to make it a weekly thing, and I hope that they become more useful and more interesting as we get all of these first pillars down, and can actually start get some structure in it. And once some structure is there, it's a lot easier to actually take a bit of it, work on it, cover it with tests, move on to the next thing, and keep that a little bit more compartmentalized. It would also be easier for me to actually show actual problems with things. Anyway, that's all for next time, and I hope to see you then. Bye.